The sea is a dangerous place. We all know of high-profile disasters, incidents that could have been prevented, lives that were needlessly lost. It's the big fires or explosions that make the news. But year in, year out, other lives are lost that we may never hear about. More tragedies that often need not have happened. Deaths caused by asphyxiation or inhaling poisonous gas don't make such good news pictures. There's nothing much to see. All the same, you end up just as dead. But there's one piece of equipment that can help save lives in all these situations. Where there's a risk of fire or explosion, breathing poisonous gas or asphyxiation. The portable gas detector. Safety procedures, like the issue of entry permits and permits to work, are vital. They're part of what keeps you and any people for whom you are responsible safe. The danger is often easy to miss. No matter how well trained someone is, they might forget, for instance, that even if they're working in the open air, gas can still be a problem. It only takes a minute amount of some gases to cause injury. What's more, many gases have no smell at all, and most are invisible. And as well as that, the problem can be extremely localized. So if someone's working very close to a purge pipe and gas is escaping from it, even though there may be no risk at deck level, at head height, it could be very different. And they may not realize until it's too late. Portable gas detectors play an essential part in many safety procedures. They're designed to help protect you, the people you work with, and the ship or installation where you work, in situations that can easily become life-threatening. The responsibility for other lives as well as your own is a heavy one, so don't make the mistake of assuming that the environment in which you and your people work is perfectly safe. You may want to remind them that all ships and shore installations have areas or spaces that can be dangerous. In fact, many enclosed spaces, including cargo holds and tanks, for instance, are simply not designed to support life under normal circumstances. You can never just assume that they are safe to enter. And many areas are unsafe only part of the time, which makes them more dangerous still. There are a huge number of reasons why a space might be or might become hazardous. For instance, a cargo like oil can give off hydrocarbon or hydrogen sulfide vapor. Both can be deadly. Some cargoes can give off flammable or toxic gas, perhaps from leaking containers or packages. Others can react with each other and give off poisonous vapors. For instance, if bleach and acid-based cleaning fluids are mixed, they can give off chlorine. Imagine this effect on a large scale. A number of bulk cargoes, timber, swarf, or scrap metal, for instance, can absorb the oxygen in the atmosphere. If the space they're in isn't ventilated, the air may not be fit to sustain life. Nearly all ships use dangerous refrigerant gases, not just those with refrigerated cargoes. Steel tanks can get corroded, a process which also absorbs oxygen. There can be a risk of combustion, and also the presence of poisonous gases if the tank has previously contained hazardous or toxic products, or contaminated ballast. Yet all too often, seafarers who should know better take unnecessary risks and allow people to enter a space that is ventilated either poorly or not at all. And once they're in that space and things begin to go wrong, it may already be too late. Even if they're lucky enough that the alarm is raised straight away, it's unlikely that anyone will be able to rescue them from the space in time. That makes safety procedures like the issuing of entry permits and permits to work all the more important. This program concentrates on gas detectors, which form an important part of safety measures of this kind. For more general information about these procedures, you'll need other training or further reading. Later in the program, we'll look at how to make sure gas detectors are working in the way you want them to. Because if you use a gas detector and it's faulty, or you don't operate it in the right way, you could face the worst of all worlds. Thinking that someone is protected when they're not. That's the way many accidents happen. So first, let's look at the three main problems that you can check for with portable gas detectors. The risk of fire or explosion because there's flammable gas in the atmosphere. The presence of toxic, that's to say, poisonous gases. And whether or not there's enough oxygen in the air to make it safe to breathe. Get it wrong, and any of these could kill someone you work with, or you yourself. Let's look first at flammable gases. So when do we need to test for flammable gas? Whenever the work you intend to do could lead to a risk of fire or explosion. For example, before starting any hot work like welding or gas cutting, or before working on electrical systems like a junction box or changing the bulb in a safety fitting. The circuit should have been isolated before you start work, but it only takes one mistake. What exactly is needed to create a fire or explosion? Three things. Oxygen, or air, of which oxygen forms a part, a source of ignition, and flammable gas. But just because a gas is flammable doesn't mean that it's dangerous all the time. In the blue area, the gas escaping from this vent stack is pure. It can't ignite because there's no oxygen present. And in this green area, it can't ignite because there's too little gas in the air. It's like a car engine. If there's too little gas, the mixture's too lean and it won't burn. The point at which there's just enough gas in the air to burn is called the lower flammable limit, or LFL. It's also sometimes referred to as the LEL, or lower explosive limit. In the blue area, the mixture's too rich and again it won't burn. This point, where there's just enough air present to allow the gas to burn, is called the upper flammable limit, or UFL. In the red area between the UFL and LFL, the gas is mixed with air in the right proportions for ignition. It's known as the flammable zone. Whenever a pure flammable gas is mixed with air, there's always a flammable zone. This is the danger area. The UFL and LFL can both be measured. The difference between them is known as the flammable range of the gas. Different gases have different flammable ranges.
I'm going to test for hydrocarbons and oxygen of 1%.
Always take precautions where there's a risk of flammable gas igniting. And that means more than just testing for gas. Make sure you follow all the relevant safety procedures. There are a lot of different kinds of gas detectors. Multifunction devices are now common, so make sure when you test that you're testing for the right thing. Usually, when you test for flammable gas, you'll be measuring how near the gas is to its LFL. But many detectors can measure for other things that have nothing to do with the LFL, so be sure of what you're testing for. Among the most common types of flammable gas detectors are catalytic instruments like this one. The catalytic process involves burning minute quantities of gas, But beware, because they work in that way, if there's less than 13% oxygen in the atmosphere, catalytic detectors won't work properly. In any event, over time, your detector may stop working correctly, or indeed at all, if it isn't properly maintained. Despite this, it may still look as if it is working and that no gas is present. Also, many detectors of this type, particularly the older and simpler models, show a reading that's above the LFL, that's to say probably within the flammable range, the danger area, with one strong deflection. After that, it usually drops to near zero, so if you're not paying attention, you could miss the danger signs. Also common, there's the heated filament type of detector. Because they don't involve any catalytic type burning, they don't need oxygen to work properly. So if you're going to test an atmosphere that's been inerted before crude oil washing, for example, they could be essential. There are also other types of detector which work by measuring things like the changes in infrared or visible light. But whichever kind you've got, you need to use it and treat it properly. The result you get is only as good as the sample you give the detector. For instance, if the tank you are testing is at positive rather than atmospheric pressure, you may get a false reading. It's no use testing if you don't look in the right place. Although most flammable gases are heavier than air, some, hydrogen, methane and carbon monoxide, for instance, are lighter. That affects the way they behave and where you should look for them. Pockets of gas may get trapped, and the situation can change. For instance, as you walk around, you may disturb scale and release vapors, so keep testing. As we've already said, poorly maintained detectors can sometimes appear as if they're working, even if they're not. You can make sure that doesn't happen by looking after the equipment properly. Replace parts like batteries regularly, but don't do it in a gas-dangerous zone. Make sure the designated person has calibrated the detector and set 0 on it. Before you use it, check the date that the instrument was last calibrated and that the batteries are okay. If there's anything you're not sure of, first read the manual, then check with your supervisor or senior officer or your safety officer. Your own personal safety and the safety of others may be at stake. Now let's look at the second major reason for using a portable gas detector. Toxic, that's to say poisonous gases, can pose a major hazard. The measurement we use to judge whether the atmosphere is safe is usually referred to as the TLV. That stands for Threshold Limit Value, which is basically the maximum concentration in the atmosphere of any particular toxic gas that is acceptable for the length of time an individual needs to spend in that atmosphere. You may not be able to use the same type of equipment to measure the TLV of a gas as you use to measure for the LFL of flammable gases. And remember, some flammable gases are also toxic. That's because the amounts you'll be measuring are much lower. For instance, the LFL, lower flammable limit, of the poisonous gas vinyl chloride is 40,000 parts per million in air. By contrast, the recommended safe working limit of the same gas is just 1 part per million. And bear in mind that you wouldn't be able to smell vinyl chloride in the air until the concentration reached 250 parts per million, more than enough to seriously endanger your health. So toxic gas detectors tend to use different ways to measure. Nowadays, there are a number of electronic devices available, but a lot of detectors still use the chemical absorption method. Each time you use one like this, you'll need to change the tube. These normally have a limited shelf life. Once fitted, a color change in the tube will show if a gas is in the atmosphere. But remember, these detectors can give inaccurate readings, if a second gas is present, for instance. But most problems occur if you don't use them in the right way. For instance, you must make sure that the detector gets a proper sample. If you don't, it won't give you an accurate result. And you need to look in the right place. As with flammable gases, different gases behave in different ways, so you need a sample from the right area if you want an accurate result. And don't forget, defective equipment can sometimes appear as if it's working. Make sure the detector you use works and is properly maintained. Check it regularly for leaks. For instance, the fact that the bellows on this device is filling with air means that the valves on the tube pump need replacing. Replace parts if you need to. Only use parts that you know come from the manufacturer. Never use second-hand or recycled parts. You could be putting lives at risk. Don't forget, if there's anything you're not sure of, check with your supervisor or your safety officer. It could be your own personal safety at stake. Now let's look at the third kind of situation in which gas detectors are used. Why is it important to check for the presence of oxygen? If someone wants to enter a space, you must make sure there's enough oxygen in the atmosphere to support life. And since it's also one of the three things that enable a fire or explosion to occur, you may need to check for it to see if there's a risk of combustion. Oxygen also reacts with some chemicals and gases. Even very low levels can cause unwelcome effects like contamination. Air normally contains about 21% oxygen. A smaller variation is 2% less, and you could already be in danger. Remember, many people who are overcome in this way don't die from straightforward asphyxiation. Instead, they fall down, and it's the head or spinal injury which results that leaves them unconscious until lack of oxygen finally kills them. So if you measure the oxygen level in a space and it's less